So, good morning, welcome to Sakala Vidya YouTube channel. Still our regular viewers are joining now. Okay, right. Okay. In the last class, actually, we have completed locus and change of axis as well as. So, now the secondary chapter, this is matrices, we are going to start. Okay. So, first let us have a discussion on the introduction about the matrices. Okay. One more suggestion, actually you need to chart regarding to the only subject content. So, not private chart shall not be allowed. So, once again please do remember. Okay. Good morning once again everyone. Okay, now let us start. Today total will be introductory part and as well as level 1 problems we shall discuss. So, you need to wait for level 2 and level 3 problems, so that it may have matrices is the actually lengthy chapter. So, we have many problems need to be completed. Okay, thank you. Right. So, what is the matrix? What is the matrix? So, the matrix is the arrangement of, I do not give the definitions and etc. So, let us go for directly. So, that is the matrix is the rectangular array or rectangular arrangement of real, one minute. Real real or complex numbers. Arranged in rows or columns. So, for example, say A is equal to some 1, 2, minus 3 and 4, and matrix B I 2 plus I 3 minus I 2 minus 1 and minus I. So, actually these are the matrices, examples for the matrices. Actually, for example, if you consider this matrices, so this is called row. So, these are called columns. That means it contains 2 rows and 2 columns. So, here regarding to this matrix, we have 2 rows whereas 3 columns. So, for example, as it contains 2 rows and 2 columns, this order is generally 2 by 2 order matrix, we call it as. Generally this is called 2 by 3, we need to write into, but we need to read it as by 2 by 3 order, this is called order. So, order of the matrix. So, for example, mn elements can be arranged in m by n order matrix, m by n order matrix. That means, for example, m n elements are there, its order will be m by n type order matrix we can prepare. This m by n type matrix is generally called, that means here m by n type means m rows and n columns and n columns. So, now generally the matrices are denoted by the capital letters. I already written capital A, capital B, capital C and dash dash. The elements are generally small letters, small a, small b, small c and dash dash. So, now general form of the matrix we shall have, general form of the matrix, general form of the matrix, form of a matrix. The general form of the matrix means will be like this: A equals to A11, A12, A13 and so on. This will be A1n, this is A21, A22, A23 and so on, A2n, this will be A31, A32, A33 and so on, A3n and so on, dash 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 dash. We can write AM1, AM2, AM3 and so on, AMN. This is called actually general form of the matrix, whose order generally we write here m by n type matrix here, m by n. See here, for example, this the element of the this matrix A11. A11 means it is the element in first row and first column, first column. Actually, the first one denotes the location of the element. A11 is located in the first row and first column. In the similar manner, for example, A23. What is the location of A23? A23 is located in the second row and third column. So, generally the rows we will count from top to bottom, 1, 2, 3, m rows. So, now actually columns will be counted from right to left, left to right, 1, 2, 3, n. That means in this matrix we have m rows and n columns. So that means now these are the A33. A33 means element which is in third row and third column. So, in general we can write, for example, Aij. Aij is the element in ith row and jth column. So, this is the actually general form of the matrix. So, this actually very lengthy. So, instead of writing this one, we can write in compact form. So, that is compact form of a matrix, or we may call it as a simplest form. So, the general form can be written in the form of a compact form. So, A is equal to, we can write Aij, this is m by n. We need to define I and j, where 1 less than or equal to I less than or equal to m, and 1 less than or equal to j less than or equal to n. So, generally the same the general matrix, this can be written like this form: A is equal to Aij m by n, where 1 less than or equal to I less than or equal to m, 1 less than or equal to j less than or equal to n. That means I take the values from 1 to m, whereas j takes the values from 1 to n. So, this is the general form, this is the compact form. I hope you have understood now. So, with the help of this actually we can, one example we shall discuss, for example, one example. So, let A is equal to Aij of 3 by 2, 3 rows 2 columns, such that Aij equals to, for example, Ij, then what is A? What is the general form of the matrix? A we need to find out. So, very simple actually. First 3 by 2 means this matrix contains 3 rows and 2 columns. So, first let us write the general form. So, A can be written like this. So, A11 first row first element, A12, A13, sorry only 2 rows, A12. Next A21, this is A22, this is A31, this is A32. That means actually 3 rows and 2 columns. Now, what is the definition? Aij means I plus j. These two actually subscripts are to be added. So, that means now this becomes like this: 1 plus 1 2, sorry 1 into 1 1, now 1 into 2 2, 2 into 1 2, 2 into 2 4, 3 into 1 3, 3 into 2 6. Yes. So, we can find with the particular definition, we can construct the matrices as for the given definition, using the definition. So, this will be useful. This is known as compact form of a matrix now. First, now we shall discuss the types of matrices. What are the types of matrices? So, types of the matrices means, let us consider compact form itself only. A is equal to Aij. For example, you say like this: 1 by n, where 1 less than or equal to j less than or equal to n, and here I is fixed, I is equal to 1 itself only one row, that means n columns. This is called actually row matrix, which has only one row. Example, so that means you can write like this: A is equal to A11, A12, A13 and so on, A1n. So, which is in the form of order is 1 by n. And one more example you can write like this: 1, 2, 3, 4, 5. This is 1 by 5. For example, you can write A is equal to A, B, C, D and so on dash dash Z. This is 1 by 26. So, if any matrix contains only one row, that is called actually here row matrix. So, now for example, A is equal to Aij. Here this is m by 1. So, 1 less than or equal to I less than or equal to m, and j is fixed only 1. This is called column matrix. So, example, one example is enough. So, like this: 1, 2, 3. How many rows? 3 rows and only one column. This is called column matrix. Okay. So, next we have, for example, A is equal to Aij, m by n, 1 less than or equal to I less than or equal to m, and 1 less than or equal to j, j less than or equal to n, such that aij equals to 0 for every I comma j, for every I comma j. So then A is called null matrix, null matrix. That means each and every element of the matrix is 0. So denoted by this is, you remember in this throughout the chapter, denoted by O. O stands for not 0, O stands for null matrix, null matrix. So null matrix you can write like this: O is equal to 0 0 0 0 0 0. This is actually 2 by 3 null matrix, or we can write O 2 by 3 also. So null matrix may be any order: 0 0 0 0 0. This will be 2 by 2. So O stands for null matrix. Understood now? Okay. Next, for example, A is equal to Aij m by n. For example, if m is equal to n, number of rows equal to number of columns, then this A is called square matrix, square matrix. Actually this is very important in matrices. We have a lot of discussion on square matrices itself only. Square matrix. A is equal to Aij m by n if m is equal to n. The number of rows equal to number of columns. So example, we can say A is equal to like this: 1 2 3 4. So this is 2 by 2, or second order this is. Some B is equal to say A1 B1 C1, A2 B2 C2, A3 B3 C3. This is 3 by 3. This is called third order. Third order. This is called second order. This square matrices. So actually in square matrices we have some concepts need to be discussed here. For example, let us consider a square matrix. A is equal to A1 B1 C1, A2 B2 C2, A3 B3 C3. This is a square matrix of order 3 by 3. So now elements from A1 to C3. So now you take like these elements. So that means actually A1 B1 A1 B2 C3 is called principal diagonal, is called principal diagonal, principal diagonal. So that means, for example, if A is equal to Aij is square matrix of n by n, for example, see this Aij is called, for example, Aij is called element of principal diagonal, principal diagonal if I equals to j. See, this will be A11, this will be first row first column, this will be second row second column, this will be third row third column. If I is equal to j, this Aij becomes the element of the principal diagonal, principal diagonal. Okay. So now for example, see A is equal to like this: 1 0 0 0 3 0 0 0 sum minus 2. Now what do you observe in this square matrix? what do you observe? Here see, except principal diagonal, the rest of the elements are zeros. So that's why it's called diagonal matrix. This is called diagonal matrix. Diagonal matrix. So that means A is equal to Aij m by n is called a diagonal matrix if Aij equals to 0, I does not equal to j. So I does not equal to j, at that time the element becomes 0. Rest of the elements will be only in principal diagonal. The one of the element principal diagonal may be 0. This is called diagonal matrix. For example, you consider this example now. A is equal to 3 0 0 0 3 0 0 0 3. Now this is called actually scalar matrix. Scalar matrix. Scalar matrix. Scalar matrix means scalar matrix is also a diagonal matrix, but all the elements of the diagonal matrix are equal. So that is called scalar matrix. For example, you consider this matrix now. For example, 1 0 0 0 1 0 0 0 1. This is also a scalar matrix, but all the elements of the principal diagonal are equal to 1. So that's why this is called, is actually what do you call, identity matrix. This is called identity matrix. Identity matrix. So that means now diagonal matrix followed by the scalar matrix followed by the identity matrix. Identity matrix. These are all from square matrices only. Square matrices. Square matrix. So diagonal means what now here? A is equal to Aij. This will be square matrix. Aij, here Aij equals to 0 when I does not equal to j. This is diagonal matrix. So this will be A is equal to Aij, square matrix n by A. So now Aij equals to 0, I does not equal to j, equal to some constant when I is equal to j. Now the identity matrix I is equal to Aij m by n, Aij equals to 0 when I does not equal to j, equal to 1 when I is equal to j. This is called identity matrix. Generally the identity matrix orders will be like this. Second order is 1 0 0 1. Third order identity matrix is 1 0 0 0 1 0 0 0 1. So this is actually identity matrix now. Okay. Next, for example, A is equal to Aij n by n. Aij equals to 0 when I greater than j, then it is called upper triangular matrix. Upper triangular matrix. Same this A is equal to Aij n by n square matrix. this Aij is equal to 0, I less than j, then this is called lower triangular matrix. Lower triangular matrix. Okay, this also we need to discuss now. Okay, now for example, so let us study properties. Properties of matrices. First, here equality of matrices. Equality of matrices. Equality of matrices. For example, when do we say that, for example, let A, B be two matrices. Two matrices, for example. When do we say that these two are equal? A comma B are equal. A comma B are equal. So that means actually you remember one thing. So first A comma B must be of same order, must be of same type or same order. Second condition need to be satisfied, corresponding elements are equal. Corresponding elements are equal. Then we say that A comma B are equal. A comma B are equal, and that is we can say A is equal to B. But actually this is called equality property. So we have the equality property is will exist on the matrices, but whereas we cannot say A greater than B or A lesser than B, we cannot say. This we cannot say. Only this will we can say. In order to say the both the matrices are equal, they must be of same order and corresponding elements are equal. So that means now, for example, you take like this: A is equal to 1 2 3 minus 4 3 1, B equals to 1 2 3 minus 4 3 1. So now observe what is the order of this matrix. This order of this matrix is 2 by 3. Order of this matrix is 2 by 3. So that means first condition is satisfied. What is the first condition? A comma B are of same order or same type. This is satisfied. Second condition, the corresponding elements. So what are the corresponding elements means here? So here 1 is corresponds to 1. That means 1 is located in the first row, first column. Here 1 is also located first row, first column, same. Similarly 2 2, 3 3, minus 4 minus 4, 3 3, 1 1. So that's why corresponding elements also same or equal. Corresponding elements are same or equal. Therefore, we can say that A is equal to B. So its converse is also true now. Its converse is also true. What is the converse means? Let me explain. For example, see, A is equal to something like this: X, Y, Z, W, and B is equal to something 1 2 3 4, such that A is equal to B. Then what is the value of x plus y plus z plus w? For example, this question is asked for us. See, already what is given actually here? These two are of same order, 2 by 2 and 2 by 2, and they are equal. They are equal means corresponding elements must be equal. X is equal to 1, y is equal to 2, z is equal to 3 and w is equal to 4. So that means x plus y plus z plus w must be equal to 1 plus 2 plus 3 plus 4. So that's we can find out the value. Understood now? Right. Okay. Now we can say that A is equal to Aij of order m by n, B is equal to something Bij of order m by n, and Aij equals to Bij, corresponding elements are equal. Then we say that A is equal to B. This is the actually definition in compact form. A is equal to Aij m by n, B is equal to Bij m by n, both have the same order and corresponding elements are equal. Then we say that both matrices are equal matrices, we can say. Okay. So now for example, A is equal to Aij of order m by n and KB a scalar. Scalar means a real number. It may be a complex number also sometimes, no problem. KB a scalar. Then what is K times A? That means multiplication of a scalar with a matrix. Multiplication of a scalar if with a matrix Ka. So this Ka is defined as K multiplied by Aij of m by n. That means you remember one thing, K is a scalar and A is a matrix of order m by n. Ka is also a matrix of order m by n, which is K of A by n. That means each and every element of this A should be multiplied with a scalar. So one example I shall discuss here. For example, A is equal to, we have 1, 2, 3, 0, minus 1, 2. Then what is 3A? What is 3A? So that means 3A equals to 3 1 ja 3, 3 2 ja 6, 3 3 ja 9, 0, minus 3, 6. We need to write like this. So that means if you want to multiply any matrix with a scalar, the each and every element of that matrix is multiplied by that scalar. This is called scalar multiplication of a matrix with a scalar. So next now see, for example, let A comma B comma C be the matrices of same order, and A is equal to Aij. Let us write compact forms whose order is m by n. B is equal to Bij whose order is m by n. C, the matrix C is equal to Cij of order m by n. First property, how to add these two matrices? So operations on, that means operations on the two matrices A plus B. So for example, if A comma B are two matrices of same order, then A plus B is also a matrix. So that means we get Aij is added with Bij, that is m by n, you will get it. So second, now what is minus A? Already we have discussed. Minus A means you will get minus Aij of m by n. Here important note, this minus A is called additive inverse, additive inverse of A, additive inverse of A. Now third point, see, A plus B is same as B plus A. Addition of matrices is commutative law, holds commutative, commutative. Similarly, A plus of B plus C is same as A plus B of plus C. This is called associative law, associative. Matrix addition is associative. And fourth point, already we have discussed here, minus A, that means A plus of minus A equals to minus A plus of A equals to, you get null matrix O. This is called, actually we have inverse property, inverse axiom. And also one more, if you add null matrix of same order, A plus O equals to O plus A equals to A, this is called identity property. These are the properties on the addition properties. Okay, commutative, associative, inverse and identity. Here we have discussed even additive inverse also, additive inverse also. Okay, next, so what is A minus B? How to find out difference of the two matrices? A and B must be of same order itself only. A minus B is nothing but A plus of inverse of, additive inverse of B should be added. This is nothing but Aij minus Bij of same order m by n you will be getting. But A minus B does not equal to B minus A. You remember, please remember, subtraction is not commutative, subtraction is not associative, only addition is. Right, next, so next, transpose of a matrix. What is the transpose of a matrix? Transpose of a matrix. Transpose of a matrix. So for example, let us consider A is equal to 1, 3, 5, 0, minus 1, 2. So for example, let us rearrange the rows and columns. So now change rows into columns, columns into rows, then you get a new matrix like this, 1, 3, 5. This row written as a 1, 3, 5. Next, the second row written as 0, minus 1, 2. Now see, a new matrix is obtained. By interchanging rows and columns, we get a new matrix, resulting matrix. This is called transpose, transpose of A, denoted by, this is denoted by A transpose, or some textbooks it may be A dash also, don't get confusion, not A inverse, A dash, both are same. Rows and columns will be interchanged. So that means now if A is equal to 1, 3, 5, 0, minus 1, 2, now A transpose is equal to, we can write like this, 1, 3, 5, 0, minus 1, 2. So that means now if A is equal to Aij of m by n, then A transpose is given by A dash Ji. That means row becomes column, column becomes row. Order of the matrix is n by m, where this Aij should be equal to A dash Ji. This is the definition of the transpose of a matrix in compact form. Please note it down, this one. This is called transpose of a matrix. Okay. So now trace of a matrix. What is the trace of a matrix? This will be very, very important for the competitive entrance examination. Trace of a matrix. The trace of a matrix is related to the only square matrix itself only. Square matrix. So understood now. So that means as in what are your actually convenient timings? Please type it now. Okay. Trace of a matrix. For example, let us consider a square matrix A is equal to, so now 1 2 3 0 3 1 1 2 3, for example 1 3. So this is 3 by 3 square matrix. So in this one, now the principal diagonal elements, principal diagonal. What are the principal diagonal elements? The principal diagonal elements are here 1 3 3. Get the sum. Sum is equal to 1 plus 3 plus 3, that is 7. This 7 is called trace of a matrix. So here trace of matrix, trace of A equal to this, we can write shortly, trace of A, sum of the principal, sum of the elements of principal diagonal. So that is 1 plus 3 plus 3, which equals to 7. That means this is the principal diagonal. The sum of these elements is nothing but the trace of a matrix. So that means, for example, let us say A is equal to Aij is m by n. What is trace of A? See, trace of A is equal to, we can write here A11 plus A22 plus A33 plus so on ANN, because A11, A22, A33 all the elements of the principal diagonal of this square matrix. This is trace. So we shall discuss the more about trace of a matrix after multiplication of the matrices. Better, we shall have a discussion there. Still we have the more concepts need to be addressed in trace of a matrix, so that we shall discuss later. So now the multiplication of the matrices. So for example, let us consider A is equal to 1 2 3 1 1 minus 1. B is equal to 2 3 4 5. Now what is the order of this A? That will be 2 by 3. What is the order of this B? 2 by 2. Can they be multiplied? Can they be multiplied? Let us check it. So, for example, here in this matrix, number of columns equal to 3, this columns. In this matrix, number of rows is equal to 2. See, you check it in matrix A, in matrix B, the number of columns is not equal to number of columns, that means number of columns not equal to number of rows. So, that means here the product of these two matrices, multiplication of these two matrices, if you say for example A into B is AB, AB is not defined, B is not defined. So, in order to multiply, for example, A is equal to something Aij, Aik m by P, B is equal to, you say Bkj is P by N. You check it now, number of columns of the first matrix A, number of rows of the second matrix B, then AB is defined. AB is defined. Then we can find out AB, that AB is equal to, we can write Cij, whose order is actually m by n type, you will get it, m by n, where this Cij equals to sigma ik into Aik into Bkj, k runs from 1 to n. This is the definition of the product of the two matrices AB. So, if number of columns of A equal to number of rows of B, then A comma B are said to be conformable for multiplication. Conformable for multiplication. Understood now? So, that means if the order of A is m by P, order of B is P by N. Here P, number of columns, number of rows same, so that they can be multiplied. The product is defined by AB, whose order is m by n type, you will get it. So, now for example, how to multiply? For example, say A is equal to 1 2 3 4, B equals to 2 1 0 3. Now, what is AB? Product of AB. So, how to find out this AB? See, this is actually in the form of 2 by 2, this is 2 by 2. See, now the number of columns is 2, number of rows is 2. So, we can find out AB, we can find out. So, that means actually see, this is 1 2 3 4 multiplied with 2 1 0 3. So, that means how to multiply means you need to follow the method is row by column method. Row by column method you need to adopt multiplication. That means we need to consider rows of the first matrix with the columns of the second matrix. For example, this is called row 1 row 2. So, this method will be, general method will be like this, row 1 row 2 multiplied with column 1 column 2. So, this is column 1 column 2. So, here we get C, first row 1 into column 1, next row 1 into column 2, row 2 into column 1, row 2 into column 2. This is the type need to be followed here now. So, how to apply here? first row this multiplied with column. So, we get 1 into 2 plus 2 into 0. Next row 1 column 1. So, 1 into 1 plus 2 into 3, row 2 column 1, that is 3 into 2 plus 4 into 0 plus 3 into 1 plus 4 into 3. Just simplify. This is 2 plus 0, 6 plus 0, 1 plus 6, 3 plus 12. So, then you can find out AB. Here BA is also possible. BA is also possible in this case. Sometimes BA may not be possible. So, properties. So, let us discuss properties of multiplication. Properties of multiplication. So, first property, if AB is defined, BA may not be defined. BA may not be defined. So, AB may not be equal to BA. That means multiplication of the matrices for conformable, not commutative, but A into BC is equal to AB of C, associative. Next, A into I equals to I into A equals to A, identity. Here, that's why I is called multiplicative identity. Multiplicative identity. So, identity. So, understood now. And one more property, what is A raised to 2? For example, A is a matrix. What is A raised to 2? So, A raised to 2 means A multiplied by A. So, what is A cube? A cube means A square into A. So, what is A power 4? A cube, A square, A cube into A. What is A power n? You can write A power n minus 1 into A. But providing you see A must be square matrix. A must be square matrix. Then only we can find out A square, A cube, A power 4 and A power n. Similarly, for example, A is a square matrix, A power m into A power n equal to A power m plus n, where m comma n belongs to here natural number or integers, then only it will be possible. So, understood now. And next, for example, if A sometimes AB is equal to BA, then A comma B are called commute, So, sometimes the product of the two matrices, that means if AB product of the two matrices may be null matrix, not 0, this is O, null matrix. So, null matrix AB is equal to O, then A does not equal to O and B does not equal to O. That means just like in algebra in general, for example, the product of the two real numbers is equal to 0 means we get like this, either A is equal to 0 or B is equal to 0 or both A, B must be equal to 0. This is real numbers. For example, A comma B are real numbers. In matrices that hold, it will not hold good. It will not hold good. That's why even though A is not a null set, B is not a null set, their product may be 0. And next thing, for example, if AB is equal to BC, then here A need not be equal to C. A does not equal to C. Okay. So now let us come to the one more property. What is the property means? AB transpose is there, that is B transpose into A transpose, reversal law, it follows reversal law. Suppose ABC transpose is there, we need to write C transpose, B transpose and A transpose. Okay. Next, for example, trace of K multiplied by A. This is K times trace of A. And second property, trace of A plus B. This is trace of A plus trace of B. I already told you, I will discuss later. I am discussing about the leftover concepts. Trace of A minus B, trace of A minus trace of B. So now the trace of BA, we do not have the trace of AB does not equal to trace A into trace B. You remember this one, this is very important. Okay. And moreover, A plus B whole transpose equal to, we can write A transpose plus B transpose. Right. So now special matrices. Special type of matrices. Special type of matrices. Okay, special type of matrices. Okay, first let A be a square matrix. Square matrix. Okay, it may be any order n by a. So first concept is, see, you consider like this example now. Say A equals to AH HB. Okay. Now find what is A transpose. What is A transpose? What is the A transpose here we get now? Again AH HB. So we get A. So that means first concept like this. If A transpose is equal to A, then A is called symmetric matrix. Symmetric matrix. Symmetric matrix. Okay. symmetric matrix. So example, so here AHHB, and one more example, a handsome guy has best friend gone for cinema. This is also transpose of the matrix is same, that's why symmetric matrix. This is symmetric matrix. Second, for example, if A transpose is equal to minus A, then A is called skew symmetric matrix. Skew symmetric matrix. Skew symmetric matrix. See example, A is equal to, consider like this, 0, 2, 3, 0, here write down 0, 5, minus 2, minus 3 and minus 5. So now find A transpose. What is the A transpose now? You get 0, 2, 3, minus 2, 0, 5, minus 3, minus 5, 0. Take minus common out from each element. If you take minus 1 common out from each and every element, what do you get now here? 0, 2, 3, minus 2, 0, 5, minus 3, minus 5, 0. Again this is nothing but A, minus 1 into A minus A. That is why it is one of the examples for the skew symmetric matrix. Okay, now this is the skew symmetric matrix, understood now? Any square matrix A can be written or expressed as a sum of a symmetric and skew symmetric matrix. Skew symmetric matrix. So that means we can write this A is equal to half multiplied by A plus A transpose plus half multiplied by A minus A transpose. See, say this is P matrix, this is Q matrix. It appears to be rather P plus Q, where here P transpose is equal to P and Q transpose is equal to, you get minus Q. That means hereafter remember A plus A transpose is symmetric, remember. This will be conceptual questions. Sometimes the conceptual questions also may be asked in the examination. A plus A transpose is always symmetric. See, A minus A transpose is skew symmetric. Skew symmetric. skew symmetric. Okay. So now so far we have discussed symmetric and skew symmetric matrices. So that means you might have understood now. So next one, let A be a square matrix such that first point, find A square. If you get A square is equal to I, that means identity matrix. A is called idempotent matrix. Idempotent matrix. Second one, A square equals to O. A is called nilpotent matrix of order 2. For example, A to the power of n is equal to O, then A is called nilpotent provided n is the least value. Because if A square is equal to 0, A cube is also become 0, but least value is 2, that is called order of 2. If A power k or A power n is equal to 0, then A is called nilpotent matrix. Okay, next we have, this is very important, A into A transpose into A equal to I. Then A is called orthogonal matrix. Orthogonal matrix. Orthogonal matrix. One minute, I will check it now. Okay. Yes, correct. This will be, sorry, A square is equal to A, then A is called idempotent. So fourth point, A square is equal to I, then A is called invaluatory. A is called invaluatory matrix. Okay. So next we have conjugate matrix. Conjugate matrix. For example, let the elements of the square matrix A be complex numbers. Elements are, for example, 2 plus I, 3 minus I, 1 and something 1 plus I. For example, the conjugate complex number of 2 plus I is 2 minus I. The conjugate complex number of 3 minus I is 3 plus I. the conjugate complex number of 1 plus I is 1 minus I. For example, this instead of this 2 plus I, if you replace 2 minus I, 3 minus I, if you replace 3 plus I, 3 plus I, in the place of 1 plus I, if you replace 1 minus I, the conjugate for 1 is 1 only, you get a new matrix now, you get a new matrix. So, if you replace them 2 minus I, this is 3 plus I, 1, 1 minus I. This is called conjugate of A. So, this denoted by A bar. And one more thing remember in this case, let me conclude as fast as A bar or A theta also you can write like this. So, now A bar transpose is equal to A, then A is called Hermitian. Hermitian. So, A bar transpose is equal to minus A, then this is called skew Hermitian. Skew Hermitian. Okay. Right. So, this is about the conjugate matrix, and also we have Hermitian and skew Hermitian. So, this is the actually total discussion on the matrices. Now, first we shall move to the problems now. I hope you might have understood all these things. Okay. Shall I move to the problems or let us wait? Okay. Okay. Thank you for cooperating with me. Still we need to complete the problem session we have today, long session. Okay. So, now the problems. First, today we discuss only level 1 problems. Problems will be very simple, but no problem. If you are interested, you can do, otherwise just skip it. Okay, no problem. Right. First problem. Let me discuss the first problem. It will be very simple, for beginners also can do the problems. X plus 3, 2y plus x, z minus 1, 4a minus z equals to 0, 7, 3, 2a. Then x plus y plus z plus a. First option minus 1, second option 0, third option 1, fourth option is 8. This is the question. Okay. Okay. So now we need to find out in this case actually now this is 2 by 2, this will be 2 by 2. That's why the two matrices can be equated. The corresponding elements are equal. That means equating the corresponding elements, only simple concept, x plus 3 equals to 0, we have x is equal to minus 3. Now the z minus 1 is equal to 3, we have z is equal to 4. Next, so 4a minus z equal to 2a, that implies 4a minus 4 equals to 2a. 2a, this is 4a minus 4a is equal to a. This 2a is equal to 4 and a equals to 2. Just we need y value now. So x plus 2y is equal to 7. So x is minus 3 plus 2y is equal to 7. 2y is equal to 10, y is equal to 5. Now you can find out. So x plus y plus z plus a. What is x? X is minus 3. What is y? 5. What is z? 4. What is a? Plus 2. That means 4 plus 2, 6 plus 5, 11 minus 3, 8. So answer is 8. So more than 3 or 4 marks will come from this chapter, maths chapter, including matrices and determinants. Second problem, if trace of A, that means trace of square matrix A equal to 6, then trace of 4A, this will be useful for not only MCET, it will be useful for all sorts of competitive entrance examination. Even this chapter is very useful for diploma students who are going to appear for ECET also. Please actually refer to those students also, because they may be getting lot of troubles in this during this period. First option is 3 by 2, second option is 2, third option is 12, fourth option is 24. Okay. Right, it may be previous problems also, don't worry, we need to get the concepts. Okay. See, for example, we know the concept, trace of some scalar multiplied by a is equal to scalar multiplied by trace of a. This concept you need to remember. So that means trace of 4a is equal to 4 times trace a. 4 times trace of a. Trace of a is given that 4. So 4 multiplied by 6. So answer is 24. So fourth option is very good, fourth option. Third problem, if trace of a equal to 2 plus I, trace may be complex number also, then trace of 2 minus I of a, this is first option 2 plus I, second option is 2 minus I, 2 minus I, third option 3, fourth option is 5. Same concept. Lokesh, leave it to discussion. Okay, right. Trace of a is equal to 2 plus I, then we need to find out trace of 2 minus I into a. For example, say this is k, so we have the same concept now, trace of ka concept. So trace of 2 minus I of a equal to 2 minus I multiplied by trace of a. So 2 minus I multiplied by 2 plus I. This is a minus b into a plus b. So we can write 2 square minus I square. 2 square is equal to 4 minus I square. Here very interesting factor need to be remembered. See, I square, I is the imaginary number, iota, I square is equal to minus 1. So 4 plus 1 equals to 5. Fourth option. Fourth problem. If trace of a 8, trace of b equal to 6, then trace of a minus 2b equals to. Today so many newcomers are there, you need to subscribe so that you will get notifications. So first option is okay, wait now, it's not working. Wait now, 1 minute. One minute. Okay. First option is minus 4, second option is 4, third option is 2, fourth option is 11. Here we have the technical problem with the digital board. Okay, now it has been rectified. Trace of a is equal to 8, trace of b is equal to 6. We need to find out trace of a minus 2b. So now the solution, trace of a minus 2b. So this we need to be written, trace of a minus 2 is the scalar, 2 times trace of b. So trace of a is given that 8 minus 2 times trace of b, 2 times 6. So this will be 8 minus 12, you are absolutely correct, minus 4. That means first option is the right option. You are very fast. Right. Fifth problem. Right. Fifth problem. If A equals to 6, 10, 100, 7, 1, 0, 0, 9, 10. So, I need to write very carefully because this is a matrices. Then trace of A transpose. First one, option minus 17, second option 17, third option is minus 1 by 17, fourth option is 1 by 17. Everybody will do. Already told you, Pavani Satya, I will follow different books for the different chapters. A equals to this one and trace of A transpose. So, am I correct? All of you need to be checked. Trace of, I didn't discuss, but trace of A transpose is equal to trace of A. Am I correct? So, trace of A means sum of the principal diagonal elements, 6 plus 1 plus 10, whose value is 17. Absolutely correct. Second option. Right, wonderful. Some previous questions may be there in this one. So, you remember this one, this is very, very important. Question number 6. If the traces of the matrices A and B are 20 and 8, then the trace of A plus B. First option 28, second option 20, third option minus 8, fourth option 12. So, I ask you all actually discuss the timings about the evening now. You make a plan. Where is Dhruhamsh? Mr. Dhruhamsh. Right. See, the traces of the matrices A, B are given 28 and trace of A plus B need to be evaluated. Solution: trace of A is 20, trace of B is 8. Now, we need to find trace of a plus b, whose value equal to trace of a plus trace of b. Trace of a is 20, trace of b is 8. This will be 28. So, first option. Okay, 3 to 5 p.m. So, what about the Ramzan timings? Anybody? Could you update me, please? (4:30 to 6) is okay. 4:30 to 6. So 4:30 to 6 p.m. Okay. Okay, I will decide. I will decide today. Thank you. Okay. Seventh question. Okay. Seventh question. 1, 2, 3, 4 plus 2x equals to 3, 5, 5, 9. Then x means matrix. First option 2, 3, 2, 5, 2, 3, 2, 5. Second option 1, 3 by 2, 1, 5 by 2. Third option -2, -3, 2, 5. Fourth option 1, 3 by 2, -1, -5 by 2. This is very simple problem that you can do it. So now this is the called matrix equation. This is called matrix equation. For example, say this is A, this plus 2x equal to B. Now we can write like this: 2x is equal to B minus A. First, from this matrix subtract this matrix. You get 3 minus 1 2, 5 minus 2 3, 5 minus 3 2, 5. Now x is equal to half multiplied by this one. Half into 2 1, this will be 3 by 2, 1, 5 by 2. Next, eighth question. Okay, today I would like to give one important announcement to you. So today I have my personal work actually, so I am not able to take up the evening classes. Tomorrow onwards I shall continue. The classes will be fixed as per your suggestions, 4:30 to 6. Thank you. Today we do not have any evening session. I have my personal work. So thank you for your cooperation. Eighth question. The additive inverse of 1 4 minus 7 minus 3 2 5 2 3 minus 1 is first option. Answer is only one step, but I need to write all the answers. This is a very difficult task to me, but your task is very easy. You are very lucky persons. 3 2 minus 5 2 3 minus 1. Second option, minus 1 minus 4 7 3 minus 2 minus 5 2 3 minus 1. Third option, minus 1 not working. What happened? Third option, minus 1 minus 4 7 3 minus 2 minus 5 and minus 2 minus 3 1. Fourth, not defined. Problem is only one step. Additive inverse of, for example, let us say this is A, additive inverse of A equals to minus A. That means each and every element of this matrix should be multiplied with minus 1. You get minus 1 minus 4 7 3 minus 2 minus 5 minus 2 minus 3 1. Which is the right option? Yes, you are correct. Third option. Radha Misala. Okay. So ninth one. Once again, actually I request to all the news viewers, please subscribe and share. A equals to, this is very important problem. Please, though it is easy, you need to be evaluated. I 0, I is the root minus 1, iota minus I, then A square equals to, first option 1 0 0 minus 1, second option minus 1 0 0 minus 1, third option 1 0 0 1, fourth option minus 1 0 0 1. So now this is the A matrix, then we need to find out A square. So A square means, you know that by the definition, A into A. That means I 0 0 minus I multiplied with I 0 0 minus I. See R1 C1, I square plus 0, 0, I into 0, 0, 0 into minus I, 0, 0 plus 0, next 0 plus I square. But I square is from complex numbers we have minus 1. This will be minus 1, 0, 0, minus 1. Take minus 1 common, you get minus I. But moreover, second option. Please remember, this will be useful for the further problems. So I 0, 0 minus I, a square is equal to minus I, not a square is equal to I here, or a square plus I equals to null matrix. Oh, we get it now. So remember this one. Tenth one. Okay, you will be getting Divya. Wait. If A equals to 1001, then 5a cube minus 7a square plus 2a equals to, first option O, not 0, don't say 0, O, null matrix, I or 0 matrix you can say. Third one A, fourth one minus 1, 0, 0, 1. See here, very interesting. A equals to 1, 0, 0, 1, nothing but A is identity matrix. So I didn't discuss actually. This A square is equal to I, A square is equal to A cube is equal to A power 4 equals to, and so on, A power n equal to I, providing n belongs to natural numbers. That means now this given expression we can write like this. Given expression, this A cube is I, 5I minus 7I plus 2I. This 5I, 7I minus 7I, that is null matrix O of second order, first one. Next 11th one. Okay. A equals to 1, 2, 3, 4, 5, 6. This is 2 by 3 matrix. B equals to 1, 0, 5. Then you need to find out product of A and B, AB. First option 1, 0, 15, that means 1 by 3 matrix. Second 4, 0, 35. Don't put the commas between the elements of a matrix. Third one 16, 34. This is 1 by 2 matrix. Fourth option is 16, 34. This is 1 by 2 matrix. This is 2 by 1. Okay, now A is equal to given and B is equal to given, then we need to find out AB. So this is the order of, actually what is the matrix now? 2 rows and 3 columns, 2 by 3. This is actually 3 rows and 1 column. If we multiply this one, order of AB will be, resulting matrix order will be 2 by 3, 2 by 3 multiplied with 3 by 1. This 3 cancel, we have 2 by 1. 2 by 1 means here 2 rows and 1 column, only option will be third one, because that is 1 by 3, 1 by 3, 2 by 1, and this will be 1 by 2. Understood now? Third option. But let us do it now. AB equals to 1, 2, 3, 4, 5, 6 multiplied by 105. Keeping view of the order of the resulting matrix, we need to multiply. This is R1, this is R2. R1 C1, R2 C1. You get like this. See, row 1, row 2 multiplied with only one column, C1. This we get row 1 C1, row 2 C1. That's why this will be 2 by 1. This equal to R1 into this one. 1 into 1 plus 2 into 0 plus 3 into 5. Next R2 C1. 4 into 1 plus 5 into 0 plus 6 into 5. So just simplify. Now what do you get now? 1 plus 15, 16, 30, this is 0, leave it, 30 plus 4, 34, whose order is 2 by 1. Okay. Twelfth problem. If A is equals to 0, 1, 1, 0, square brackets or round brackets you can put, no problem, and B equals to 1, 0, 0, 1, then AB plus BA equals to, first option A, second option 2A, third option 3A, fourth option 4A. This is the problem. See, here A equals to 0, 1, 1, 0, but here interesting, B is the identity matrix, B is equal to I. That means we have identity property, A into I is A. Sorry, 1 minute, I shall come to the. So AB equals to A into I, that becomes A. Even BA also I into A. That means we need to find out AB plus BA. A plus A is 2A. That's all. Second option. So today we don't have the class. Tomorrow onwards we will make 4:30 to 6. Okay. Okay, next 13th one. If A equals to 2304, then A square minus 5i. First option 418 0 16, second one minus 1 18 0 11, third option 1 minus 13 5 minus 11, fourth option 1 minus 13 5 11. So now A is equal to given, let us find out A square. That means 2304 multiplied with 2304. Now I will do directly, already you might have practiced. See, 2 into 2 4 plus 0, 6 plus 12, 0 plus 0, 0 0 plus 0, 0 plus 16. This is A square. So we have 4 18 0 16. Now 5i. I means identity matrix of 2 by 2 only, because A is 2 by 2. So 5 multiplied by 1001, that will be 5005. Rest of the thing you can do it. A square minus 5i. That means you need to subtract 5005 from this 418 0 16. 4 minus 5 minus 1, 18 minus 0 18, 0 minus 0 0, 16 minus 5 is 11. Second option. Okay, this can be done actually in a higher level, means whenever you go for gate examination, that is this can be done eigenvalues. In engineering we have eigenvalues, that I will explain also, don't worry. What is very simple means A minus, not functioning, what happened today? A minus lambda I determinant equal to 0, you need to do it. You get a equation in terms of lambda, quadratic equation. In the place of lambda replace A, you get this equation. This is called Cayley-Hamilton theorem. This is called Cayley-Hamilton theorem. With the help of this we find out eigenvalues. Eigenvalues. This will be higher standard. You are going to discuss in your IITs and engineerings. When you enter in the there, you will discuss. Okay, now today we have very lengthy session. So thank you one and all. See you tomorrow. We shall have the class by same time, 10 o'clock. Thank you. Bye. See you.